It was really interesting by Dimitri to see the trends which were highlighted in my previous predecessor speaker here, where the trend is going. And I would like to highlight from a private company perspective where innovation is going, as an example from Bayer AG. And you might know our company, which is a pharmaceutical company. You probably know aspirin. All of you, if you've got a headache, this is pretty famous. And probably 2/3 of our turnover is generated by pharmaceutical products, and 1/3 is generated in agriculture, mainly crop protection, but also seeds and traits. And I would like to give you a few examples where innovation is going to be placed in a company like Bayer. We heard a lot about Syngenta and Monsanto. There's another company out there, which is Bayer AG. And I would like to highlight our innovation in chemical research, what we're doing to find new chemistries, new molecules, new structures for the control of pests and diseases. Some words about breeding, some words about trait research, our biological department, which is scheduled to grow. Some words about the digital farming, which was mentioned by Dimitri as well. And our let's say, experimental station forward farming, which we are having outside in the market. What is our mission? Science for a better life. This applies to agriculture, it applies to innovation, it applies to the healthcare part, and really our mission is really to supply to the growing world market, to the growing population in the world, safe and food supply and pharmaceutical products, really to heal patients if it's needed. That's our global innovation mission. To give you a few numbers, the global turnover of our company is around 46 billion euros. We have more than 110,000 employees worldwide. And we are spending in R&D, research and development, probably more than 4.5 billion every year to make these kind of innovations in pharmaceuticals, but also in agriculture. I think Dimitri mentioned already that the main challenges in agriculture, we need to supply a global food production by 2050 for a growing population. And the population globally might grow about another 2 billion in probably 30 years' time. We have a change of the consumers' patterns. So if you go to China, more meat consumption is showing up there versus 30 years ago. We still have a lot of people out there, be it in Africa, be it in Asia, and some part really suffering from hunger. We have still room for improvement if it comes to the storage of food and feed. And due to the growing population, we still have a decreasing acreage available per capita, as you can see. And the weather was already mentioned as a consequence of climate change. So things have to be addressed. We need different varieties with different profiles in order to address all these aspects. Our company started with a chemical product more than 100 years ago. And today we've got in chemicals our herbicide, fungicide, insecticide, and seed growth or seed treatment products, which are well established here in Russia as well. We have a different new department in biological and seeds, where we are working with microbial fungicides, really to control certain diseases and certain pests. And but this is not the end of the story. If we look further, what's going on here, I think, sorry, oh, can I go back, this one? Yeah, there's new challenging going up there. And it's new players in agriculture. It's companies like Bosch or Fuji who've never been in agriculture, but they're applying data management, they're applying data collected throughout the harbors of the field and using this with a certain mathematic algorithm really to do this kind of digital farming, which was mentioned already by Dimitri. Robotics are coming, new product concepts. We have genome editing, besides the gene technologies, and we have the urban farming, which was mentioned by Dimitri in the same way, where we need to address certain challenges. So Let me start with when I started working with Bayer nearly 30 years ago, we were probably checking 10,000 molecules per year in order to develop the products we have on the market today. Now, if you see what we're doing now, the improvement is really to go to a certain automatic robot system, really, to get amounts up to 100,000 compounds per year in a testing system to get a first reaction with very small amounts of this chemical if there is any interactive activity available. And it turns down to the normal primary screening, secondary screening, and profiling in the field in a way which allows us really to select the very beginning of this small amount of chemicals until the final product, which is then offered to the market and to the farmers globally. Breeding. I think we have heard a lot of research in trade development. Breeding is a classical way. It started with selection. It continued with crossing. And one of the examples I would like to show here is the use of markers. And if you see, let's say, the cost of the markers in the 90s, which were about $20 per marker, and it goes down to more or less nothing. And in the same time, the amount of markers used for breeding has increased dramatically. You can see it on these statistics without going into detail. This is today a standard procedure and helps us to develop far more faster than in the previous time the desired varieties and with the desired traits. Another point is the use of robotics. So we have a robot tractor, more or less, who checks the fields automatically with certain devices. And let's say if an employee or a breeder could manage 100 to 160, 200 plots a day, we're far away from that, then we could manage 1,000 plots per day with these robots. And this data are going into an algorithm, and at the end delivers the results of the breeding work we want to see in order to be able to select the right varieties we are behind. Trade research. What is trade research? I think if we go back to breeding, if we just use this chart, which is a little bit chaotic, mentions all the aspects in breeding and trade research which are in the discussion today. Let's say we start with land traces of variety, be it in sugar beet, be it in maize, be it in cereals or wheat, doesn't matter. And now you see all these techniques which has started to go from mutagenesis, which has continued to be applied in gene-modified organisms, and now we have these gene editing technologies, or in some words it's called new breeding techniques, which is discussed all over the world. What is it? I think Dimitri has mentioned already CRISPR-Cas, which is one of these methods. There are lots of others available here, and I think as university, as academia, all the private companies, not only Syngenta and Monsanto, but also Bayer, are working on these technologies in agriculture, but also in pharmaceuticals, and even in the nutrition part, these technologies are used. The problem today is we have only in a few countries regulatory clearance. What is these kind of products coming out of these methodologies? At the end, is it a GM plant or is it a non-GM plant, or what kind of plant it is? And I think, as Dimitri has mentioned, CRISPR-Cas, there is one aspect where CRISPR-Cas could really be a GM plant, but there's other technologies which will not end up in a GM plant. But this is under discussion with all the regulators in the United States and Latin America, in Europe, in China and India. It's under discussion the same way. Here, you know better how the state of the discussion is, but I think in this area, the new solutions for the next 25, 30 years will come out of this area using these technologies. And this is the reason why we as Bayer are also interested in understanding the technology and making use out of it in order to get in a relatively fast way new and improved varieties with new traits. There is a certain principle established how these methods should be regulated. This is now from the International Seed Federation, some statements which at the end mean that any regulation of these technologies should be based on science, should not be based on any political decision. And we have in Europe some of these examples that this is not the case. And at the end, regulation is necessary if it's based on sound science, but if it's not based on sound science, we should better stay away from this kind of regulation if it's not based on science. What else? Trade research. Now we are coming to biological products. What is a biological product? It could be applied as a spray, as a seed treatment, or a soil drench organization. It is a bacteria, it is an organism which is able to produce either metabolites or proteins or peptides in order to control certain diseases, certain pests. It could produce a toxin where a problem is to be solved. The biological products are not as efficient as a chemical product, certainly not, but they are biological, and they may have an efficiency of 70–80% versus a chemical might reach up to whatever, 90–95% of efficacy. But the societal acceptance all over the world is increasing for these kind of products, and this is the reason why Bayer, on top of other companies, are investing in these technologies. This is the last acquisition we have done in California. It's 5 acres, nearly $100 million investment, where really products are already on the market, and we are, let's say, working on the system that biological product could be part of the entire crop management system, starting with the seed, continued with the pest and weed control, and fertilizing systems, at the end, if needed, surrounded by a biological product. Digital farming, big data. I think this was already mentioned as a trend by Dimitri already. I think this is also a research area for us. You have discussed the pros and the cons of these technologies, and I might say not everywhere this technology will apply and will have its fit. You have somewhere in the world excellent farmers who know all these details, which are brought in an algorithm here, but you have other farmers who don't have this knowledge and know-how. So in order to increase food supply, to increase food security at the end, this is one tool really to make food supply more stable and more better forecasted. Look at what's already going on outside of agriculture. With digitalization, look at the largest taxi company, Uber, doesn't own any taxi. The largest real estate company, Airbnb, doesn't own any real estate. And so it's continuing, and having seen these modern combines, be it a combine for wheat, be it or for corn or whatever, they're measuring data, they're measuring the yield every square meter, and monitor this on a certain map. You could pretty much forecast in which part of your field you will have a higher yield and where you will have a lower yield. And this is exactly what precision farming from our perspective is about. At the end, it's a technology optimizing the crop management under certain weather conditions, soil conditions, climatical conditions, whatever, from the very beginning to the harvest. And by each cycle of planting and harvesting, new data are being generated, and the next season is even a better one in order to make this formula a living formula, because the yield is really an interaction of the genetic, which is in the seed, the theoretical yield potential, with the interaction in the environment and the crop management available. So we do this still in an experimental stage, more or less in all the major markets. We were even planning one here in Russia, but you see Europe, North and Latin America, but we are still in the experimental phase. It's not yet ready to be marketed. And a simple example, if you have certain weed problems, like here, you have a standardized spraying technique which really applies the chemical there where the problem is available on the field, and there will be no application in other parts of the field where this weed problem doesn't exist. That's the idea, the overall goal, but still a long time to go to have this developed. Forward farming, I think having all this know-how internally in our let's say, organization, that's one thing, but we need to share this with the outside world, with the real customers, with the growers all over the world. And this is why we have this forward farming, or in Russia it's called Bayarena, where we demonstrate to our partners, let's say, cropping systems, the knowledge, the partnership, our dialogue. We are learning from each other really as a platform under given circumstances, under given conditions, what is the best way to produce whatever crop it is. And here we have examples from all over the world. This is now an example from Germany. And here in Russia, we have these kind of Bayarenias, where we have, I think in Krasnodar, Lipetsk, Kursk, and Bryansk, these kind of stations where we do our production technique for all the crops relevant here, be it sugar beet, be it corn, or be it cereals, or potatoes, doesn't matter, at the end to demonstrate how it is and to share the agricultural technology and expertise with the experts in a certain region, and really make sure that a lot of visitors are coming there and seeing how this is going to be done. This is now an example from, I think it was in Krasnodar. Very important to have this interaction, and it's not only a gift from our side, it's also a take from our side. We are learning from each other, and that's the way we believe we should benefit from the innovation. The most important point for me, it's not one thing which makes a difference. It's not chemical research. It's not only breeding. It's not only trade research. It's all of them. All these aspects are needed, and if I come back to Dimitri's speech, I think even more aspects might be needed in future to address global food supply and secure this one. And I hope with this short summary I have shared with you that with all these challenges mentioned here, we have at least our part to contribute to overcome these challenges at a certain point in time, to increase food supply, to reduce hunger, to feed the growing population. And with this, I'm ready for your questions. Thank you.
My name is Natalia. I'm from Krasnodar, and as I know, your company doesn't have biological crop protection in Russia. And can you explain why? Thank you.
We have products all over the world, and at the end, it's always a balance between the cost of a registration and the expected turnover at the time being. In this particular case, the cost of registration by far outreached the scheduled sales we have foreseen for this product at the time being. I think when agriculture will develop with all these opportunities we have seen here by Dimitri, and more advancement are achieved at a certain point in time, I think the market will be ready for this kind of product as well, but just not at the time being. It's just a pure math. Welcome.
Thank you for your presentation. Yesterday we watched the film about 10 big, large companies in the world which controls all these technologies, 70% of technologies in the world. And there was some fact that fertilizers in the world are limited, and it's not yes, fertilizers, mineral fertilizers, and there's no way in the future how to make our harvest more, and it's a road to the hunger in the world. In the maybe after tens or 100 years, what will our future in the fertilizers?
I think it's a good question, and I agree. At a certain point in time, I think the fertilizer beat now. Nitrogen is a question of energy providing. So nitrogen could be produced. We have a lot in the air. That's one thing. But if it comes to potash, that's a different story. So the quantities are limited. I think all the research which is underway globally is really to improve crop management systems, to make better use out of the existing amount of fertilizers. You might do something in breeding to have a better use of fertilizer, better use of potash, better use of nitrogen. And if you see in Western Europe today, I think if I say the nitrogen application is 100%, only 60% are used in the crop. So 40% is, at the end, it's wasted. Be it diluted into water, be it somewhere in the air, whatever. If we achieve to get a 20% better use, this helps already a little bit in the direction as your question is. I think we need to improve the crop management system. We need to have better traits in our plant, which are able to make better use out of the existing fertilizer, which are limited at a certain point in time. I think this is the way to go into further innovation and make a better use out of what is existing.
Hello.
Sorry.
Yeah, I already have a mic. So, yeah, hi, my name is Pavel. I'm from Stanford Business School, and I did research on AgTech there in the U.S. And the question is about Bay Area and kind of adoption of new technologies by farmers. So, what are some of the challenges you face, and how do you sell these precision farming tools? What is the business model? How do you prove that there is a value in it? And if there are any, like, you have any numbers in terms of extra yield or cost reduction based on your tests, would be interesting to hear your views.
I think it goes back to the point as already just mentioned. I think if you've got a good variety, if you've got a good fertilizer regime, if you've got a good, let's say, crop protection array of products, that's one aspect. But how to apply them in the right way, this is the know-how of a certain grower under certain growing conditions. If you go to Krasnodar area, they have certain conditions which are just true over there. And even if you have two neighboring farms, the yield difference might be 20%. What is the reason for this? And to me, it's just about crop management, to get at the right time, the right decision, the right application. And this is what we are trying to achieve in the Bay Arenas. This is what we are trying to achieve in the forward farming all over the world, to have a locally adapted system. And I cannot stand here and say, this is the way to do it. It's changing every year, and it needs to be adjusted to the local weather, soil climatical area, agricultural condition under a certain environmental pressure. And this is different from year to year, but this is what we are trying to achieve. So if you have a fusarium infection in wheat, for example, it's depending on the weather. If it's hot like now, if it's humid away, you might be needed to look more intensively at this stage of a crop, what the fusarium infection is about, and if there is a need to spray. I don't know if this answers your question, but I think it's all about improving of the crop management, which goes at the end back to digital farming, the huge algorithm, or to the sophisticated know-how of a particular grower who is running a farm.
Thank you. I just wanted to narrow my question. So, in terms of like, how do you persuade farmers to try and test the technology? Like, how do you offer them the value? And do you see like significant increase in
We see it on our forward farming or on the bio-arena that people who are interested in these kind of technologies, how we apply the products, they just see it, they learn it, and take it home. There is no other incentive. It's the yield which we are going to demonstrate, and it's convincing by just showing the better results.
Thank you.
So thank you for your presentation. If we're speaking about the movie that we watched last day, it was a documentary movie, and there were rather controversial information. The author of the movie went to Bayer, and they told that they invented or they developed rice hybrids, for example, for the flute, for example. So, or for giraffe, I don't remember. Actually, and I went to India, and there was 2 fields. On one field, there were a hybrid that they bought in some corporation, and the other field, it was their native rice. And during the flood, hybrid died. Every hybrid on this field were dead. But the native, but not very effective, but it's survived during this. And they told that they don't want to buy hybrids because it died. So what can you say about such kind of thing?
I think it's a really good question, and again, it applies not only to rice and hybrid rice, it applies to, at the end, other crops in the same way. So if you have a flooding area, if you're the risk of flooding, you better plant whatever a local adapted variety is. But the hybrid rice we develop is really for fields where the flooding is normally not occurring, and here the potential yield increase, which is in the dimension of 25% versus the land races, can materialize. But if you've got the flooding, of course, it will never work. Of course not. And it comes back to the point I just tried to mention earlier. All these tools which are available, be it a hybrid variety, be it an open pollinating variety, it needs to be positioned in the right way. And you've got the flooding exposure, you better don't plant it, of course not. This is for area where this risk doesn't show up in a regular case. Yeah? Okay?
May I? Thank you for the interesting presentation. My name is Angela Saturova, Krasnodar City. I have two questions. First, what's your opinion? The main problem in your company with interaction between Russian farmers and your company?
I don't know if I understand your question right. Maybe the interaction between our company and the Russian customers, or?
Yes. And for example, your company and American farmers.
Again, we're a global company. We are having subsidiaries in all the major countries in the world, not only from the agricultural, but also from a pharmaceutical perspective. We are present in all the markets. This is true for Russia, this is true for the United States. And the exchange with the growers is on a pure technical, is on a partnering level. And this is the same here in Russia, especially in Krasnodar.
So the same.
I don't see any difference, no. Maybe
and the second, are you looking for in Russia new technologies, new products? If your company look in Russia only such a resource of market?
I think for us, Russia is one of the major markets. It's the largest country in the world with if you see the arable land available here. And I think if you see the yield level, there's still a lot of room for improvement. It's not so easy, even if you have the Chernozem soils, but the weather conditions are somewhat different compared to other countries. There's challenges, but I think there's room for improvement in the crop management system. And with this background, Russia is really a key country for us as a research-based company, yes. That's true in other countries in the same way. It's true for Western European, it's true for North and Latin American countries. But we need to see the limitation if we are in Siberia or in Kazakhstan, where we have growing seasons from let's say mid of May to mid of September. You have different conditions versus in Krasnodar, in your country, where you're from. So this needs to be addressed, and the limitations are there. But still, under these conditions, there is room for improvement. And this is where we're investing in new products. if your question was raised to gene technology, yes, we do have these technologies. We in the United States and Latin America working on gene-modified crops. We have a Roundup Ready, we have a Liberty Link Ready canola in Canada. We're working in cotton on these kinds of solutions in markets where this is accepted. Whereas in Europe, there is no acceptance, so we just don't do it. We do it in a traditional way. And as I see the seeds legislation here in Russia going forward, I think Russia is in the similar route. So we're just trying to address the needs with different tools out of this toolbox. And if it comes to, the question was already raised by a biological product, I think at the time being, this is probably not yet the mark, but if you see the larger cities and maybe some vegetable production around the larger cities in glasshouses, there could be at a certain point in time a market for this kind of product, and then of course we will offer it. But as long as the registration costs are still far above any potential sales opportunities, I trust on your understanding that we can't afford it. That's just a simple math, yeah?
Thank you.
Hello? Just one small question. You mentioned the different bioproducts like biopesticides. I know the currently it's around 2% of the global markets of chemicals, let's say. And you mentioned that one of the main limiting factors is low efficiency, which is 70%. What if there is a technology that brings it up to 90 or 95%? What do you think would be the share of the bioproducts now?
I think over time we will get, of course, better biological products, but we need to be realistic. It's a living system. It's living in the environment. It's not produced in stainless steel tubes. So the interactions with the environment are there, and which at the end means there is a certain limitation. Is it at 70%, 80%? Could we improve it to 90%? I wouldn't exclude it, but it's certainly more difficult because it's in the living organism with lots of interaction with the environment.
What if those problems are solved and confirmedly solved now?
If you want to give you a number now, so I can give you a frame. There's room for improvement from current status, yes, but if we ever are able to achieve 100%, I doubt this due to the interaction with the environment. Yeah? Any other question? If not, thank you very much, and see you next time.